In this video, we're going to discuss the domain and range of quadratic functions. The domain of a quadratic function, the domain of any function, is all of the x values that the graph will take on. The range is all of the y values that the graph will take on. Let's start with the domain. The domain of any parabola, of any quadratic function, is always going to be all real numbers, because no matter, regardless of whether the parabola opens upwards or downwards, the parabola keeps on going on and on and on and on. It keeps on getting wider and wider and wider forever. Past the end of the page, off the sheet, keeps on going, and it's always going to be all x values, so the domain is always all real numbers. The range, however, let's first look at a parabola that's opening upwards. The range is only going to be the minimum value and every y value that's greater than the minimum value. It's never going to go below the minimum values. It's never going to be anything over here for that graph. How about the other graph? How about the graph that's opening downwards? The range is going to be the maximum value and everything below the maximum value, because the graph is never going to go above. The graph is never going to be over here. So when you're given a picture of a graph, a parabola like this, it's very easy to see what the domain you know is going to be all reals. The domain is all real numbers. But the range will sometimes be more difficult. When you're given a graph, it won't be, because you see the minimum value very easily. The minimum value is y is equal to positive 1, so the range is going to be all y values that are greater than or equal to positive 1. Let's say you're given a graph that opens downwards. Say you're given a graph over here. The domain you know is going to be all reals, and the range, it's going to be all of the numbers that are below this maximum point. This maximum point occurs at y is equal to -2, so the range is going to be all numbers less than or equal to -2. All the y values keep on going down. Let's say, however, you're just given an equation. Let's say you're given the equation y is equal to x squared plus 5x plus 1. Without graphing it on paper, how do you know what the range is going to be? You could graph it on your calculator and have your calculator tell you what the minimum or maximum point is, and then it's very easy to figure out the range. Let's do that. So in y equals, we're going to type the equation, x squared plus 5x plus 1. Let's graph it in zoom standard, so we're going to do zoom 6. Here we see our parabola, and we see where our minimum value is. It's right over here, but we don't know exactly what value this is. So we're going to have the calculator tell us. To do that, we're going to go into the calc menu. We're going to press the second button, and notice that it's in blue. So when we press trace, we're really activating the little word in blue that says calc. Trace. And we see that our parabola, we saw that this parabola was opening upwards, which means that it had a minimum point. So we're going to scroll down to 3 for minimum. Press enter. And now we're just going to find the minimum. We need to find left bound, so we're going to go all the way to the left of the minimum. And press enter. Then we need to find the right bound, so we're going to go all the way to the right of the minimum point and press enter. And then we need to guess, so we're going to go to where we think the minimum is and press enter. They tell us that this minimum is 2.50000001 and comma -5.25. We don't care about the x value, we care about the minimum y value because we're determining the range. We know that the domain of this is automatically going to be all reals. We're looking for the range. So since it opens upwards, we know that our range is going to be y is greater than or equal to everything that's greater than -5.25. So our range is going to include -5.25 and everything that's greater than -5.25. Let's look at another example. Let's say we have the equation y is equal to -x squared minus 2x minus 6. And let's graph this. So we know the domain is automatically going to be all real numbers. And we want to find the range. So let's graph this. Go into y equals, we'll clear out the old one. And the new one is -x squared. Sorry about that. negative x squared minus 2x minus 6, and we'll do zoom 6 for zoom standard. Now we see where our maximum point is. We see that the parabola opens downwards, so we have a maximum point. And our range is going to be this maximum point and everything that's less than it, because the parabola keeps on going downwards. So we're going to have the calculator tell us what is the maximum point. We're going to back into the calc menu, so second trace for the calc menu. Scroll down to 4 for maximum. Press enter. Left bound, we're going to go all the way to the left of the maximum. Enter. Right bound, we're going to go all the way to the right of the maximum. And enter. And guess. Somewhere in the middle over there. And press enter. So we see here our maximum occurs at -1, -5. We don't care about the x value. We only care about what is the maximum y. The maximum y is -5. So our range is going to be y is less than or equal to every value that's less than or equal to -5.